Hello everyone, and welcome to my channel AI and Automation Tools for Everyday Use. In today's video, I'm excited to share a milestone in a robotics project I've been working on. Using the physics simulator PyBullet and the Franka Emika Panda robotic arm, I was able to build a working robot simulation that can reach, grasp, and lift an object using a robotic gripper. If you've been following my recent experiments, you know that I've been exploring advanced AI systems like HRM and combining them with automation tools. The natural next step was to see how these technologies could eventually control a robot in a simulated environment. So in this video, I'll walk you through what I built and what it means. First, let's talk about the simulation environment. I used a robotic simulation platform called PyBullet. PyBullet is widely used in robotics research and allows developers to simulate robots, physics, and interactions with objects. This makes it possible to develop and test robotic behaviors without needing a physical robot. Inside the simulation, I loaded a robotic arm called the Franka Emika Panda. This is a 7-axis robotic arm with a 2-finger gripper, commonly used in robotics labs and AI research. The goal of the experiment was simple: get the robot to pick up a cube. But getting a robot to do that is not as simple as it sounds. First, the robot has to move its arm using something called inverse kinematics. Inverse kinematics calculates the joint angles required for the robot's end effector, the gripper, to reach a specific position in space. Once the robot can reach the cube, the gripper has to open and close correctly. That means controlling the finger joints so the robot can actually grasp an object. Next, the robot needs to align the cube properly between the fingers. This required careful tuning of the cube's position relative to the gripper frame. Even small offsets of just a few millimeters can cause the robot to grab the cube incorrectly. After the fingers close, the simulation attaches the cube to the gripper using a physics constraint. This allows the robot to lift the cube naturally within the physics simulation. Finally, the robot lifts the object upward, demonstrating a complete grasping action. What you're seeing here may look simple, but it represents several key robotics concepts working together. In other words, this small demo contains the same fundamental building blocks used in real robotic systems for warehouses, manufacturing lines, and automated laboratories. This is an exciting step because now that the robot can pick up an object, we can start adding more capabilities. For example, the robot could be programmed to pick up multiple cubes and place them in different locations, like a pick-and-place system used in factories. Another interesting step would be to add a camera to the robot so it can detect objects automatically instead of relying on hard-coded coordinates. And eventually, I'd like to connect this simulation with AI reasoning systems, such as HRM, so that the robot can decide what actions to take. That would turn this project from a simple robotics demo into a true AI-driven robotic system. If you're interested in AI, robotics, automation tools, and practical experiments like this, make sure to subscribe to the channel. I'll be sharing more videos showing how these systems are built step by step, including the code, the tools, and the lessons learned along the way. And if you have ideas for what this robot should do next, feel free to leave a comment below. I'd love to hear your suggestions. Thanks for watching, and I'll see you in the next video.